Okay, guys, we're in Math 116, section 4.3. We're going to do a full simplex method problem. Prepare to be amazed. Okay, this is question number 25 on page 294. Sorry, I was looking it up. Okay, question 25 says maximize. Maximize f, the function, is equal to 3x plus 10y subject to, those subjects, as soon as you see subject to, you think, I'm in for either a big graphing thing or a simplex method thing. 14x plus 7y less than or equal to 35. We have two inequalities, and 5x plus 5y is less than or equal to 50. And since you've probably seen that previous video that I made many times, you will remember that this number of inequalities here, we have two inequalities, or two, I think of them as equations, but they're really actually inequalities. That means we have two slack variables. So the first thing we want to do is set up our augmented matrix. So we have here, I should make an augmented matrix, x, y, slacker variable 1, slacker variable 2, our function, which I'll call z, and then we have constants. So this isn't the row, this is just me getting organized. I don't know why I started on this middle paint picture. So the first row are the coefficients of the first inequality, so it's 14, 7, I'll go here, 14, 7, slacker variable 1 goes with this guy, and the constant is 35. 35. The second equation gives us our second row, so that's 5, 5, and then this is slacker variable 2, and we get 50. So here we have 5, x is 5, coefficient of y is 5. This represents slacker variable 2, and we have 50. And our final row, as you recall, is the maximizing variable. So suppose we say call this function z. Well, then we know if we bring all of this onto the other side, so we can set this equal to 0, that becomes negative 3x plus 10y minus, minus 10y, whoo, that was close, plus z equals 0, because we brought the x onto that side, so subtract x, subtract 10, so minus 3x minus 10y plus z equals 0. So we have minus 3 minus 10, no slackers, 1z, and we know that all equals 0. And again, since this was from the equation, we draw the line like this and like that. So that is our beginning of our augmented matrix. So we start. Here's where we start. And again, you can borrow heavily from the procedural box on page, there's a really nice thing the book does where they kind of spell it all out, page 285. So note, page 285 has these step-by-step procedures. So the first thing you do is you look down here and you think, oh, look at these negative numbers. So you take the most negative number, so the largest negative number, but negative numbers, you know, the most negative is 10. So that tells us to focus on this column. And again, I'm not interested in having you understand necessarily the derivation of this process. Just understand how to do it. Negative 10, so we're looking at this second column. And we say, well, here's what you do after that. You say, I take 35 divided by 7. Take this number divided by 7. That equals 5. And then you take this number, 50, divided by 5. It's sort of like a beginning game to see who gets to start. That's how I think of it, like sort of a rock, paper, scissors to see who gets to start. So you take 35 divided by 7, that's 5. 50 divided by 5, that's 10. And you look for the smallest one. Smallest gets to start. Okay? Youngest gets to start. So 5. And they go, all right, that's 5. What do we do with that? Well, that tells us that this number here, 7, is going to be our pivot point. What does it mean to be a pivot point? Well, I'll show you. Just calm down. So what I'm going to do now is I'm going to rewrite this matrix on another page and really highlight this 7 as the pivot point. Hold on. Okay, I'm back. So here's our pivot point. This 7 is our pivot point. And by the pivot point, That means we want this 7 to be a 1, we want it to be a 1, and we want everything else to be a 0. We want it to be 1, 0, 0. So we're going to manipulate this matrix, similar to what we did with the Gauss-Jordan method, until we get 1, 0, 0 right here. That's all we're doing. Just focus on that little thing. So the first thing we want to do is divide everything by... I don't like having a 7 there. I just don't. I want that to be a 1. So I'm going to take row 1, and I'm going to multiply it by 1/7. So I'm basically dividing all of row 1 by 7. So I'm going to say that becomes 2, because it's divided by 7. Divided by 7, that becomes 1. 1/7, 0, 0. 35 divided by 7 is 5. And I haven't done anything to the rest of the rows, so I'm just going to leave them in white to represent the fact that I haven't done anything. Okay. I'm going to run out of a little paper very soon here. Okay, -10, 0, 0, 1, 0. Hold on, I'm going to rewrite this. That's a 3, that number right there. So again, we are pivoting on this 1. That's our pivot point. I like to make a square around it. So that's good. I like that there's a 1 there, but now I want these two to both be 0. So we're going to do something very similar that we did in the Gauss-Jordan method. So in order to get this to be 1 and that to be 0, I'm going to leave the first row the same because I'm happy with that. So that's just going to stay as 2, 1, 1/7, 0, 0, 5. But now my second row, I want this to be a 0. So I'm going to multiply -5 times row 1 and add it to row 2. So if I take -5 times there, add it to that, I'll get -5 plus 5 is 0. So -5 times 2 is -10 plus 5 is negative, I'll make it yellow to show that I changed it, -5. -5 times 1 is -5 plus 5 is 0. That's what I wanted. -5 times, oh, that's -5/7. What? Oh well, that's fine. 0 plus 1 is 1. 0 plus 0 is 0. 5 times -5 is -25 plus 50 is 25. Okay, so far so good. I have a 1 and a 0. Now I want a 0 in my final row also. So I have a 10 here, so I'm going to multiply. I'm going to take 10 times row 1 and add it to row 3. Take this one times that. 10 times that to get here. So 2 times 10 is 20. 20 plus -3 is 17. Okay. And then 10 times, that's 10 plus -10 is 0. Okay. Then 10 times 1/7 is 10/7. So this becomes 10/7. 10 times 0, 0. 10 times 0 is 0 plus 1 is 1. And then 10 times 5 is 50, plus 0 is 50. Ooh. So, I just did that. So now I have 1, 0, 0. I like that very much. So I'm done with step 1. Because I got this, I looked at my pivot point. Remember I said this was my pivot point. And I got my pivot point here. I got this into, sorry I lost it. Here's my 1, 0, 0. Here. To 1, 0, 0. Okay, so now once you've done that, once you have your first pivot point number, and it looks like this column now is 1, 0, 0, you stop, you take a moment, and then you look. Stop, look. Do you listen? You can listen if you like. But you're basically looking for negative numbers. In this case, these are all positive. Look at the last row. We have 17, 10/7, 1, and 50. These are all positive numbers. That is excellent. That means we can stop. We are done. You were trying to get this into all positive numbers, if you remember from the other video. So again, I'm going to pause it, rewrite this, and we'll find the solution. We're almost done. Here we are again. So here's the matrix. I want that to be red. And remember, this column represented x, y, slacker 1, slacker 2, the function, which we called z, and this was our constant. So the way you solve these, once you have all positives, is you say this is your maximum. So our goal was to maximize this function. Well, what is the maximum? It is right here. Oh, right here. So we say the maximum is 50. That's why it's in this box all by itself. Yay, maximum is 50 when, and now you look at these columns. So because all these are weird numbers, that tells us x equals 0. And when I say weird numbers, I mean it's not 1, 0, 0. So because there's numbers here, that tells us that x equals 0 is the answer. You see that? You look at this column. This is the x column. So there's not one, it's not lined up nicely like the y column. That tells us the answer is x equals 0. So write x equals 0. The y column, look at the y column. Oh, that's nice. We have 1, 0, 0. So the 1 goes with the 5 because the y column, the 1 is up here, so that goes with the 5. And y equals 5. We don't really care about the slacker variables. Just leave it. Who cares? They're slackers. So that's our answer. How easy was that? Maximum is 50 when y is 5 and x is 0. And that is your answer. So again, you should be able to do a problem like this with 2 equations, and that one we only had to do the whole method one time to get our answer. I found a YouTube video where a guy does it a couple of times, so the more complicated problems you have to do the more sort of iterations of the same process, and obviously there's computer programs that do this for you, but you should be able to do one smaller matrix like this on your own for the test. Good job, you guys!